Hi guys, this is Mr. Bennett, and I wanted to go over the Unit 10 study guide just in case you were unable to make the review today after school. So let's go through it step by step. Question 1 says, what are the main parts of a chemical reaction? What can be written on the arrow, and what do those symbols mean? So typically on the left-hand side you're going to have your reactants, and then in the middle you're going to have your arrow, that's the yield sign, and then you're going to have your products. So whatever formulas fit those substances, the reactants and the products, reactants will be written on the left, products will be written on the right. The only other thing that can show up in this equation, at least as we know it right now, is there may be a catalyst. If there's a catalyst, it's always written above the arrow. And so that way it tells us that it's not part of or it's not being used as a reactant or a product within the reaction, so it's not going to be used up and it's not going to be made, but it is participating in the reaction, and it does that by making the reaction happen faster. That's why we use catalysts. Okay. Question 2 says, why is the law of conservation mass important for balancing chemical equations? Well, when we have an equation like this with reactants to products, it's important that the number of atoms for each element on the reactant side needs to equal the number of atoms for each product on the product side. In other words, the reaction can't use up or destroy elements, it can't destroy matter, nor can it create matter. So if you had 4 carbons to begin with, you have to have 4 carbons to end with. It has to balance out so that we conserve mass. We can't create mass and we can't destroy mass. We can only rearrange it. So the next question is, what is a coefficient? So throughout the unit we've written some chemical equations. So for instance, if I had H2 plus O2 produces or yields H2O, we have written numbers in front of those chemical compounds that have balanced out our equation. So for instance, in this one we need to balance out, we need to balance out the oxygens. There's 2 on the left, and we need to have 2 on the right, and if we do that we need to add another number in front of the hydrogen so that we have 4 hydrogens on the left and 4 on the right. Those numbers that we put in front, this guy right here, that is the coefficient. Okay? So number 4 says, explain how to balance a chemical equation. Well, first thing is we need to add coefficients to adjust the number of atoms of the reactants to equal the products. Okay, and there's lots of ways we can do this, but I think I've tried to emphasize that I think the method that seems to be the most successful right now to most students is if you actually list the reactants that are in the problem. So for instance, our problem up top, if I list that there's hydrogen and oxygen, and then I count up the number of each element in the reactant side and in the product side. So up top in the reactant side, initially before we added the coefficients, we had 2 hydrogens and we had 2 oxygens. On the product side we had 2 hydrogens, but we only had 1 oxygen, so we needed to make this balanced. In order to balance it, we added a coefficient of 2 on the right hand side, the product side, which meant that we went from having 1 oxygen to 2 oxygens so that they would be equal. But when we did that, it also changed the hydrogens, so the hydrogens now equal 4 on the product side, so we then had to add a coefficient of 2 on the left side, the reactant side, to make sure that we had 4 hydrogens, and so that the number of hydrogens in the reactants would equal the number of products. Okay? Now, question 5 says, be able to write the chemical formulas for the following compounds. For ionic compounds, I think they are the trickiest. Okay? So the first thing is, you know it's an ionic compound if there's a metal in the name, and we know how to identify metals. Metals are to the left of the staircase on the periodic table, but you know it's ionic if there's a metal in the name. Also, if you see a Roman numeral, because transition metals have Roman numerals in their names. The Roman numeral tells you their charge. It actually makes them nice to deal with. Okay? If they're not a transition metal, then you have to determine the charge. Remember the column that has hydrogen in it? Even though hydrogen isn't a metal, that's the +1 column. And then you count to the right, you get to +2, and then to +3, right, on the periodic table that is. And then counting from the other side, remember the noble gases on the far right, they don't have a charge, things like neon and helium. But if you start with fluorine, fluorine has a -1, and then next to fluorine you have oxygen, which is -2, and then next to oxygen you have nitrogen, which is -3, and then you get to carbon, which is at ±4, right? So once you have your charges, let's say for instance you were looking up magnesium, so they tell you that it contains magnesium and fluoride, right? Well, when you look up magnesium on the periodic table, it's in the second column from the left, which means it has a +2 charge. Fluorine is in that first column, closest to the noble gases on the right-hand side, so it's a -1. To figure out the formula, we crisscross. Ionic compounds are all about crisscross. So we take this charge number and we give it to fluorine on the bottom, take this charge number and give it to magnesium, so it's Mg1F2. However, we never write subscripts of 1, so I can erase that, and so our formula is MgF2. That's magnesium fluoride. We just crisscross the charges. The last thing about ionics is that if it contains a polyatomic atom, right, polyatomic ion, polyatomic ions are on the back of your resource page. Those are going to be things like hydroxide, sulfate. We've glued this into your notebook, so you have a list of those available to you if you have your notebook tonight. But also, they will be on the resource page, the back of the resource page that you get to take the test. Okay? Covalent compounds, they're easy. The prefix tells you the subscript. So in other words, if it's dihydrogen monoxide, that's H2O. Okay? And so, again, the prefix tells you the subscript. Okay, they're the super easy ones. So if you get like tetracarbon, right, that's going to be C for carbon and a subscript 4. So covalent compounds are super easy. Like, they tell you in the name what the subscripts are going to be. They're awesome. Okay? And last but not least, we have the diatomic molecules. Don't forget your diatomics, please. Diatomics, remember the mnemonic. Have no fear of ice. Cold, remember cold is chlorine. Beer. And when we write their formulas, all of those elements, when they're by themselves, when they're pure, you give them a subscript of 2 because they're diatomics, and diatomics mean, di means 2. So it's going to be H2 or Cl2 or I2. Okay? Last question deals with the 5 types of chemical reactions. Make sure you can identify them. Number 1, I don't want to see anyone miss this one, combustion. Please be able to spot it. It's the easiest one. O2 is the reactant. That's how you tell. Whoops, didn't mean to go back. Okay, but O2 is the reactant. That's how like upset I am if anyone misses this. O2 is a reactant. Don't miss it. It's easy. It's on the left-hand side of the arrow. If it has an O2, it's combustion. Okay? Number 2, easiest one, is synthesis. If anything, you're going to forget the word. Okay? But don't forget, synthesis is taking 2 things, 2 substances, and putting them together to make one substance. It's easy peasy to spot. Number 3 for spotting is decomposition, or to decompose, but we call it decomposition. Again, super easy to spot. Please don't miss this. It's the opposite of synthesis. So you take a substance that contains more than one element, and you split it up into smaller pieces. Okay? Now the displacements. They are still easy. Okay? Don't get hung up on them. So single displacement, I'm just going to abbreviate it here. Remember, you're going to have a single element. It might be a diatomic, so don't get messed up by that. So for instance, you could get a diatomic like, let's say you have a compound, AB, plus O, let's not do O2, plus I2, because that's our diatomic, right? Produces. And then we get I, whatever substance B is, plus A. Okay, we know this is single displacement because we have a single compound right here and a single element on the left side. We have a single compound and a single element on the right side. Hence, single displacement. With double displacement, you'll see the bump. You'll see 2 compounds, and they'll just swap pieces. Okay? As far as giving examples, check them. Check them in your notes. Go back to 10.3, find some. We've got plenty. We went over it today in class. But good luck on the test tomorrow, and email me or send me a question on Emoto if you have any problems. Alright guys, good luck and see you Monday.